Hello everyone, I'm going to present a contribution to the 13th International Conference on Computational Intelligence in Security for Information Systems. The title is Offline Writer Verification Using Segments of Handwritten Samples and Support Vector Machines. This work has been developed by Matilde Santos from the Complutense University of Madrid, Spain, Marco Mora, who belongs to the Catholic University of Maule, Chile, and myself, Veronica Odin, from the National University of La Matanza, Argentina. The outline of this presentation is as follows. First, we will present the writer verification problem that we're going to deal with. Then, we will present how we have dealt with this problem, dividing the characters into segments. Afterwards, we will describe the descriptor that we have used for the classification using support vector machines. Then we will discuss the results, and finally, we will end with the conclusions and future works. The analysis of handwritten strokes is an issue widely studied in the literature due to its multiple and useful real-world applications. Among them, we can mention the classification of ancient documents, signature verification, studies on the relationship between writing and different neurological disorder, prediction of the writer's gender or age, security and access control, and the most relevant to this work, forensic handwriting analysis. Writer recognition includes two different issues, the author's identification and the author's verification. Verification takes place when it is proved that the author of a document is who claims to be its writer, whereas identification consists in discovering who the writer of a certain document is from a group of known people. In handwriting, visible features such as the shape of the letter are easier to imitate. However, handwriting invisible features such as pressure, direction, and continuity cannot be perceived by a forger, and that is why they are so difficult to copy. They provide relevant information for the identification. Pressure is one of the features of handwriting that can be taken into account for the comparison with a real sample. This is due to the fact that pressure is not always uniformly applied when forming strokes, and there are particular variations that allow writer's differentiation. We see here the threshold samples of two people. The red points correspond to those with the highest pressure, and the blue ones to the lowest pressure. We can see that the location of the point of greatest pressure is different for the two people, but that it remains almost constant for the same person. An interesting idea is to use together the gray value and the relative position of the characteristic pressure points within the trace. This allows the pressure pattern of the stroke to be more accurately represented. We propose to consider the four quadrants of a circle as the segments to work with. For the sketch, they follow a clockwise and counterclockwise direction in order to cover all the movements of the hand. As a result, there are 8 defined curved segments. They have different curvatures and direction, which make it possible to capture each person's typical handwriting features. For the sake of simplicity in this work, it is assumed that a grapheme is formed by one or more of these basic segments. In order to generate an image repository of segments, the database of simple graphemes was adopted, which was previously used by the author. That database contains samples of the following symbols that can be seen on the screen. From this grapheme, 6 basic segments were extracted. 50 writers were considered with 10 samples per segment. These parts of the stroke were semi-automatically extracted, painting the segments and extracting the colored zone of the image. The proposed descriptor corresponds to a representation of the writing pressure pattern estimated from the grayscale image of a handwritten stroke. We will work with the average level of gray of the point of the stroke located on the perpendicular line. This new descriptor better represents the complete pressure distribution of the stroke, since it considers in its calculation all the points on the perpendicular line to the skeleton, that is, All the important variations in pressure along the stroke are taken into account, measured by the level of grade. Besides, the transfer variations are not the result of pressure difference. In order to estimate this pressure descriptor, the morphological skeleton of the stroke is first obtained. Once the stroke has been skeletonized, the perpendicular line to the skeleton is calculated for each of these points. Then the descriptor is obtained, taking into account the average for each point of the skeleton. 50 support vector machine binary classifiers have been applied using the proposed descriptor to differentiate the 50 people that took part in the study. To carry out the experiment, 100 balanced groups were considered. Two types of cross-validation were used to test the robustness of the classification system: K-fold cross-validation with K5 and leave-one-out cross-validation. The average hit rate of the 100 balanced group is reported as global performance measurement. This table shows the average results for the 50 individuals and each segment. The row corresponds to each segment, and the first column shows the percentage of hits for her K-fold. The second column shows the results for leave-one-out cross-validation. It is shown that the success rates obtained are high for every segment, reaching a 97% average of success for the 6 segments for the first validation scheme, and results are even better using the leave-one-out cross-validation, reaching a higher percentage of hits. The results obtained show that even taking any of the segments individually as a descriptor, it is possible to verify the writer identity from handwritten text with a high rate of success. Another alternative that has been considered is to take as a descriptor more than one segment at the same time. Indeed, all segments belonging to one person have been combined in one class. This figure shows the results of one series that correspond to the evaluation of the 50 individuals. Each value of the series in this figure represents one person's results, and it is calculated as the average of the results obtained from the evaluation of the descriptor for the 100 balanced groups that belong to that person. It can be seen that there is low data distribution dispersion. In fact, 75% of the values can be found about 98.8%. The hit rate obtained for each of the 50 people, considering all the samples of the 6 basic segments, is always between 99 and 100%. Now we'll present the conclusions. This paper proposes a writer identity verification methodology that consists in dividing graphemes into basic segments. Up to 8 different curved segments have been used as descriptors to verify one person's identity. This division into segments is interesting because it makes it possible to extract a higher number of features from a text than those that use a complete grapheme or even the signature. Besides, this set of features has low dimensionality, which leads to a higher processing speed. The proposed descriptor is based on the pressure measurement. Particularly, it corresponds to the average of the gray letters on the perpendicular line to the skeleton. Some interesting properties of the proposed descriptor are that it is invariant to rotation and to scale, making it a general one. The evaluation results are quite good. A hit average of 98% was obtained for each of the 6 segments proposed. The combined use of these segments improved the performance up to 99% of hits in identity verification. As future works, the development of an identification method based on the same methodology would be interesting, using segments from a database of text paragraphs. Another possible aim would be to automatically extract these segments from the text, using descriptors and other classification techniques, such as neural networks, would be other possible future researches. Thank you very much for your attention and your time.